We're continuing with section 14.7, and we're trying to this time use the second derivative test, basically. Example 1. Find and classify the critical points of f of x and y equal to 3x squared minus 6xy plus 5y squared and plus y cubed. So let's first find them. Finding them involves finding the gradient vector. So set the derivative partial with respect to x of the function is going to be here 6x and over here minus 6y, and then nothing else. For partial with respect to x, partial with respect to y is this one is 0, this one is negative 6x, and 10y and 3y squared. Now that you know the gradient, the next step is to set each component. That's the partial with respect to x equal to 0, and then partial with respect to y equal to 0. Now over here what you get is x is equal to y, and then from there put it back in here, replace x with y to solve. That's how we solve systems, right? Most times, I guess. Plus 10y plus 3y squared equal to 0. That is 4y is equal plus 3y squared equal to 0. Factor y. And then y equal to 0 and y equal to negative 4/3 are going to be two answers. Okay, so what about x? Go back to the first equation that you found, and that means that x has to be the same as y. So how the equation work, the two equations work is if both of them are the same and either 0, 0 or negative 4/3 and 4/3, negative 4/3. Now you basically found the critical points, two critical points, 1 and 2. What you need to do next is to classify each of them. To classify each of them, you have to use the second derivative test. So let's find the second derivative, the discriminant. Discriminant here, this was f sub x and this was f sub y. So f sub x is going to be equal to 6. F sub x y is going to be negative 6. F sub y is going to be equal to, let's see, 10 plus 6y. Now, basically, when you're finding a discriminant, this time is going to be 6 times, that is 60 plus 36y minus 6 to the power 2, which is negative 36. Add and subtract and you get 24 plus 36y, and that's the discriminant. Now that we found the discriminant, what you need to do is plug in these two to see what the discriminant of each of them is going to be. So let's say 1, 0, 0, and the other one is negative 4/3 and negative 4/3. When I plug in 0, 0 in the discriminant of 0 and 0 is going to be equal to 24. It's a positive value. Going back, if I look at the f sub xx, of 0 and 0 is positive. Therefore, there is a local minimum. Here, if I find the discriminant at -4/3 and -4/3, it's going to be 36 times -4/3, which is 12 times negative 12 times 4, which is -48 plus 24. It gives you -24. This is a negative value, so a saddle point. And so that's how you basically characterize the in both of the critical points. I click here question A, 14.7a. Suppose 1 and 1 is a critical point of the function f with continuous second derivatives. F sub xx of 1 and 1 equal to 7, f sub xy of 1 and 1 equal to 8, and partial respect to yy at 1 and 1 equal to 10. What can you say about f? So take a pause and come back and answer. So first step is to calculate d of 1 and 1. And that would be 7 times 10, 70, minus 8 to the power 2, 64. And that equals to 6 positive. F of xx at 1, 1 is positive. Therefore, there is a local minimum. And C is the answer. I click here question 14.7b. Suppose 1 and 1 is a critical point of a function f with the continuous second derivatives. F sub xx of 1 and 1 equal to 7, f sub xy of 1 and 1 equal to 9, and f sub yy of 1 and 1 equal to 10. What can you say about f? Again, critical point, so let's form the discriminant, and discriminant is this times this, which is 70, minus 9 to the power 2, which is 81. That is negative 11. It's a negative value. I don't have to even know about f sub xx. All I need to know is this is a saddle point.